Indiana, and I am the state soil health specialist. So I cover the entire state of Indiana, working with our Indiana Conservation Partnership employees, farmers and landowners, doing education and outreach on soil health. So it's really a big passion of mine. So thank you for inviting me to speak today, and hopefully you guys will get excited about soil health and want to do some of these things too. So basic things I'm going to go over is I'm going to start with a little bit of background on soils just to put us all on the same page. And then I'm going to go into soil health. And then at the very end, I'll go over some things about NRCS assistance if you're interested in using that to implement some of these practices. So first thing is, what is soil? I mean, we've all probably touched it. We walk on it. We see it every day, but we're going to break some basics down. It's made of four main components. So the first thing is minerals, which is your sand, silt, and clay components. Your second thing is going to be your water. So that is going to be the water that gets held in the soil after it rains, or your groundwater that's going to be there. And then air is really, really important because our roots for our plants need air, and so does a lot of our soil biology. And this is actually going to be held in the pore space. So this is in between where the minerals don't fit together tightly. There's going to be space for air or water to be there, as well as between our soil aggregates. So an aggregate is a bunch of soil held together and clumped together. That you would see if you break out a shovel full of soil and natural pieces break off. Those are soil aggregates. And then the last thing is organic matter. So that's dead and decomposed plants and animals. That's our carbon source. That's going to hold on to water, hold on to nutrients, and help stick those soil particles together. So soil's formed by a series of 5 factors, and these factors are going to influence a lot of our properties of our soil. So it's important to understand what goes into making a soil. So the first thing is going to be your parent material, which is what is broken down to make your soil. So in Indiana, we have 2 types of glacial, because Indiana has been glaciated multiple times in history, and things have been dragged and pushed around and moved. So those glacial parent materials will have material that actually came all the way from Canada in them. So pretty interesting. We also have wind blown, so it's really, really fine things that have moved with the wind. We have things that move with water. So these are especially prevalent in our floodplains. And then we have organic, which is a lot of decomposed plants and very little minerals. These are normally a wetland type soil. So think like Grand Kankakee Marsh in the northwest part of the state. And then once we have something that we're breaking down, the climate is going to affect how that breaks down. So if it's warmer, there's going to be more biology breaking down that residue and that organic matter component of the soil. And if it's higher precipitation, it's going to move minerals throughout the soil profile because things are going to leach and move deeper. So all of that's going to affect what that soil looks like. And then our biology, because our biology is going to influence the organic matter, like we talked about with climate. It's also going to change chemical composition as it breaks things down. And topography. So slope, the direction that the hill is facing, that you're going to get more sun, less sun. It's going to be warmer, cooler. The elevation. So if you're up in the mountains, it's going to be really different than if you're down in a valley somewhere, or when you're in the Midwest versus being in Florida at sea level. So all of that's going to be very, very different. And then time. Obviously, the longer time you have to process something, the deeper and more soil you're going to get. So all of those things play in. And then we can divide those soil properties into inherent and dynamic soil properties. So inherent soil properties are the ones that are affected by those soil forming factors, and we can't really do much about them. So texture, the amount of sand, silt, and clay you have in your soil, that comes from your parent material. Your drainage class, we can alter that by putting in artificial drainage, but as soon as we pull that drainage out, it's going to go back to what it used to be. So really can't change that permanently. And then type of clay, that's also a parent material thing. That's a where you are on the world thing as well. There's 3 different types that are kind of spread over the globe. So depending on where you are, that's going to dictate what type of clay you have in your soil, which that can in fact like shrink, swell, and that kind of thing. But we don't have a lot of issues with that in Indiana. So dynamic soil properties are the soil properties that we can change. So this is what we do with management. It's also natural disturbances. So big rain events, droughts, floods, all of those things can change these. So organic matter, our biology or our soil food web, our structure or our stability of those aggregates that I talked about, infiltration, which is water moving into the soil. So when we have a rain event, how much water can move in, how quickly. And then soil fertility and pH, which if you guys are farmers, this is huge. You're used to, testing the soil, looking at your nutrients, figuring out what your crops need. Obviously, we're affecting that when we're farming. So those are kind of the basics to get us all on the same page. So now let's get into the fun stuff. So soil health is kind of a buzzword right now. So is sustainability, so is regenerative. And I want to make sure we all have the same definition that I'm talking about while we're doing this. So it's the continued capacity of the soil to function. So we want the soil to perform certain functions for us as a vital living ecosystem. So everything needs to be alive. Sorry, my computer's going crazy there for a second. That's going to sustain plants, animals, and humans. So again, that life. So this little collage of pictures, we've got cover crops, we've got bugs, we've got roots, we've got earthworms, we've got soybeans, corn, all of these things are alive. So soil properties can be broken down into biological, chemical, and physical. And traditional agronomy has looked at, for hundreds of years, the physical and chemical properties of the soil, which are really, really important. But we've kind of forgotten about that biological aspect, which is what soil health is doing. And 90% of soil function is dependent on the biological properties. So it's a really, really important part of our soil function that we've kind of been ignoring. So that's why soil health is kind of caught on, and we're really looking at that definition as the life in the soil and the life that soil can sustain. So I said we want soil to provide functions. What do we want it to do? First of all, we need it to produce what we're growing as our crop, right? Food, feed, fiber, biofuels, medicine, whatever's out there. So we want it to sustain our crop because we put those inputs out there. That's our livelihood. We want to make sure that's working. Capturing, filtering, and storing water. So the water that comes from the sky is rain. You obviously want it to go into the soil, be held for our crops, and then be filtered of any contaminants or anything that might be in there. We don't want it to erode because we want our soil to stay where our soil is supposed to be. We don't want it to move off site and go into the nearest water body and either go to the Gulf of Mexico, Lake Erie, or Lake Michigan, depending on where you are in Indiana. So we want to keep our soil where it's supposed to be. We want it to cycle nutrients because we can put inputs into our soil, but those are expensive and cost money. And if we can get some of the nutrients from a natural process and it's actually cycling through that soil food web, it can be a huge benefit to us. And then resilience. So I'm sure everyone has noticed that the weather patterns are changing. We are getting more rain in less frequent events. So we're getting huge rain events, but we're getting them all spread out, 6 inches at a time instead of an inch here, an inch there. We've got longer dry periods during the summer, which all of these things are causing flooding. We've got temperature extremes. We were just talking before this started about how dang hot it has been. So doing all of this with our soil is going to keep our plants happier because we're making that resilience. Sorry, my computer is doing all kinds of things here. Sorry, guys, this is going to be a great recording. Protecting plants from pathogens and stress. So if we've got a healthy plant and healthy soil, we're going to have less pathogens and stress on there. So that is really going to help our bottom line and not having to put in those treatments. And we're going to have healthier plants with hopefully higher yields. And then storing carbon and moderating the release of gases. So I'm sure everyone's heard about carbon credits and all of that that's revolving out in the world right now. Agriculture can be a great carbon sink because that organic matter in the soil can hold on to a lot of carbon. But in order to do that, we have to have a healthy system that's not getting disturbed all the time. So we hope that the soil can provide that carbon sink for us and not release a ton of greenhouse gases back into the atmosphere. So we use 4 main principles to talk about soil health here in Indiana, and I'll go through each of these, and then I will also go through some practices that we can use. So minimizing disturbance is going to be looking at minimizing not only physical disturbance through tillage, but minimizing disturbance through disruptions of over applying nutrients or pesticides or fungicides or those types of things. So the more we disturb the soil, the more we break natural processes within the soil biology, as well as break up the soil aggregates and the soil structure. So we want to try and minimize as much of that as possible. Maximizing biodiversity is also key because diversity above ground equals diversity below ground. So the more types of plants, the more types of animals, the more we kind of switch everything up above ground, the more complete that soil food web is going to be. And this can be through switching up the types of plants that are there, as well as adding in livestock into the system if that's applicable. And then maximizing soil cover. So soil cover acts like armor for our soil. It keeps the soil covered so that the raindrops don't dislodge soil particles, because a raindrop can hit the soil at 25 to 30 miles an hour. So when it hits, we get what we call splash erosion. It takes soil particles up if that soil is not covered and splashes them up, and then those come over and seal the soil surface and make it so that no water can get into the soil. And when it dries out, it forms like a really crusty surface. So the next time it rains, it definitely is not going to get any water, and it's going to get even less than the last time. It also can moderate temperature, so it can be up to 20 degrees cooler in the summer underneath cover than it is on a bare ground. So I heard somebody say once, and I've always used it too, tilled soil that's exposed with no soil cover, it's naked, hungry, and thirsty. It doesn't have anything for the biology to eat, doesn't have any cover to keep it cool and hold that water in. So it's not a happy place. Mother Nature does not like uncovered soil, which honestly is why when we till our soil and have it all uncovered, Mother Nature likes to put weeds out there because it's trying to put cover out there. And then the last one is maximizing living roots. So every day that we have something growing, roots are going to exude sugars. And then those sugars are going to feed our soil biology. So the more roots that we have growing and the more days we have that going, the more active that soil biology is going to be and the more complete it's going to be because we're actually feeding it. Even when it's cold and snowy and it doesn't look like anything's happening, it may be moving slower underground, but with that insulation from the armor on the soil and then the insulation from the actual growing plants and the warmth of those microbes themselves creating, it'll actually still be functioning underground. It may just be moving a little slower than it would under like ideal temperature in the spring or the fall. And within those principles, we can kind of divide them into two camps. So there's feeding the soil. So that's fueling the soil biology. We're improving the resilience and we're improving that organic matter because the plant material and the dead microbes and things are being broken down to become that stable organic matter. And the other camp is we're protecting them. So organism habitat, we're protecting that structure and those aggregates and that organic matter that already exists. So we can kind of divide those principles into two camps where maximizing living roots and maximizing diversity feed, and minimizing disturbance and maximizing cover protect. So easy way to think about it. And we're looking at a systems approach for this. So one thing is great, but we need a lot of different things to work together to make this work, to make a complete system. So it's okay to step in slowly, but you can't stall out and quit or you're never going to get all the way there. So first thing to talk about is a quality reduced or no-till system. So taking tillage as much out of the equation as possible. And it says quality because we've got to have planters set correctly. We've got to have our combines set correctly. We've got to, if you're hand planting on a small farm with veggies or that type of thing, we've got to figure out how are you getting the seeds or the transplants in the ground with as little disturbance as possible. So all of that is going to make a huge difference. We can't just, throw old equipment out there or throw equipment that we haven't dialed in out there and expect to get great results. Diverse and strategic cover crops. So this is where that biodiversity can come in. If we can add different plant types in between our cash crops and grow those cover crops over the winter, or in a higher intensity vegetable rotation, try and get them in those midsummer or end of summer spots where you've got stuff open before fall crops come in. Doing that is going to help not only the soil health, but it's going to break up pest and disease cycles and those kind of things as well to make your crops healthier. And we've got to look at goals and figure out where we want to go with them so that we're not just throwing something out there, because obviously cover crop seed costs money, it costs time, and if you're driving equipment to plant it, it's going to cost, gas and diesel. So we want to make sure what we're putting out there is meeting a goal and we're planning ahead, because if you try and buy cover crop seed in August for something that you want to plant in the end of September, there's not going to be a lot left and it's going to be real expensive. So making that plan ahead of time and really treating it like your crop and doing that plan ahead is super, super important. And adapted nutrient management. So we all know across fields or between different garden beds and those kind of things, nutrient management is going to be different depending on the soils, depending on your crop, depending on your previous crop. All of those things are going to play in. So we want to adapt that nutrient management to the area that we're in. And that may mean that you have different zones across the field or different zones between beds. And that nutrient management, we should be putting on the right rate at the right time, at the right place with the right source. So those are called the 4 R's. So those are really, really important to make sure we're avoiding that disturbance of the system. So we're not over applying or applying the wrong nutrients that maybe aren't needed when we do need something else. So weed and pest management, we call it integrated weed and pest management. Really, this depends a lot on scouting. So we need to make sure we know what's out there and we're checking things. We also need to know our economic threshold levels for our crops so that we know, hey, is this pest really bad enough that I need to do a treatment, or am I going to not lose a lot and I'd rather keep that soil food web functioning and keep from applying something? Because we all know when we apply something, it has unintended consequences, right? And sometimes it's needed because we are going to lose our entire crop if we don't do something about this pest. But sometimes it's a small enough amount of them that it's okay and we can let it go and we've got just a very, very slight loss. So keeping all of that in mind is really important, because the more things that we put on, like insecticides, pesticides, all of those things, if we're not doing them for a very specific purpose and we're doing them as more of a keeping from panicking type of thing, we can have unintended consequences. Diverse crop rotations, again, going back to that biodiversity and trying to get as many types of plants out there as we can. This also, again, breaks pest and disease cycles, helps with all of that to better manage that soil food web. And then buffers and edge of field practices. So a lot of people don't think about these when they're looking at a soil health system, but thinking about adding diversity in places that maybe you're not getting a return on investment. So in a field, it can be along a tree row where it's shaded and you're putting in those inputs to plant your crop, but then you're not getting a lot out of it because the yield's reduced. Or maybe small corners where it's hard to get equipment, or in, a small farm scenario, maybe along the edges of a bed where, you've just got a space where nothing else will fit. That would be a great place to look at something for pollinators, which are also going to help you with your pollination of your crops. So these just provide beneficial insect habitat, pollinator habitat, wildlife habitat in areas where you otherwise may not be getting something out of it. And then precision farming technology. So to the capability of the equipment that you have, the more precise we can make things, the better off we are, because that way we can make everything match up as close as possible to where we want it. We can even precision plant, let's say, cover crops right down the row where you're later going to plant corn so that you have the nutrients exactly where you want it. It's not a requirement, but it is something that really helps if that is a possibility with the equipment and the budget, because that stuff is expensive. So a lot of people get it a little at a time. So let's talk about some practices. So reduce till, no till, and strip till. So you've kind of got the 3 types of conservation tillage, or what we like to put under conservation tillage. Reduce till is just like it sounds. It's taking out tillage passes. So maybe just doing spring tillage instead of doing fall tillage. Maybe you're doing less tillage passes, so you're only doing 2 instead of 4. Every time we can take a disturbance out, we are helping our soil biology and our soil structure. The ideal would be going to no-till, which would be no tillage at all. However, sometimes the in between also works, which is strip till, which is only tilling up, small strips and leaving most of the field untouched. And we're only just tilling where we're planting. So all three of them are going to give you different degrees of helping with that disturbance and cover and diversity, but all three of them are valid depending on what crops you have and what your operation is ready for and what equipment you have. And cover crops. So we like cover crops a lot. Indiana, we had 1.7 million acres last year of cover crops and overwintering crops, but the overwintering crops are a very small percentage of that because we don't plant a lot of wheat or anything like that in Indiana. Most of that was cover crops. So that's a pretty big deal. That's the number 3 state in the nation for cover crops. So we're pretty proud of that. A lot of Indiana farmers have signed on to this. And this is kind of the easiest soil health practice to start with, I feel like, because you're putting it out there when you don't have another crop. Of course, you need to plan for what species you're going to plant and then how you're going to terminate it and what crop you are planting after it. But it does add that cover diversity and living roots to help feed that soil biology. And we've found that when you're starting a soil health system, your soil biology takes some time to get up and going because it's been a reduced system for so long with a lot of our traditional farming practices. So cover crops are a great way to kind of dip your toes in and jumpstart that system before you even start reducing tillage and doing those types of things. And then nutrient management, we talked a little bit about that disturbance factor, trying to figure out how do we still get our nutrients to our crops that we need, but the least amount of disturbance to the natural cycles as possible. So using those 4 R's and working through that is super, super important. And then pest management. Again, this can look like scouting. This can look like knowing your economic threshold levels for your crops. This can also look like flowering like insectary strips in between veggie crops for beneficial insects and pollinators. So there's a lot of different ways this plays in, and it really helps address that disturbance and that diversity principle that we talked about. Crop rotation, again, if you're looking at row crops, most of the things that we plant in Indiana are corn and beans, just because that's what we have the outlets for. Wheat is one that people have started adding back in if they do have a place to sell it, which we do have some elevators in Indiana that will take wheat. There's also, some specialty crops and those kind of things that can be put in depending on where you are in the state. So looking at trying to get that crop in at a different time or a different type of crop in is super helpful. And again, that conservation cover and wildlife habitat for that diversity and those buffers. And that's going to address all 4 soil health principles. So that's a really great way to take those edges of the field that aren't working well and make them work for you in a way that builds your soil health. And then if you've got livestock, looking at rotational grazing, so taking a large pasture and dividing it into paddocks and giving that grass time to rest and rotating that livestock through should give you not only better soil health because we're reducing compaction, but it will give you better plant health because we're giving that plant time to rest, and everything is working out really well to get that livestock the best quality feed we can. And it's also giving that plant the best quality that it can give, and hopefully sending down those roots and putting out those sugars and keeping that biology active. And then planting pasture and hayland or renovating it, because traditionally we've lost a lot of legumes and things out of our pastures because they've been overgrazed. So getting that cover and diversity and those roots back in there are really helpful to an existing pasture, or maybe taking some marginal crop ground that isn't doing so well, it's erosive, not real high yielding, and turning it into a pasture is an option, and one that if you have livestock is something to definitely look at. And then for a small farm, veggie crops, mulching is also super helpful. We can use the existing mulch from a cover crop, but a lot of people also use additional natural mulches like hay, straw, grass, leaves, all kinds of things. That just keeps our soil covered and gives our soil that armor, and also reduces some disturbance, especially if we incorporate some kind of minimal till or no-till practice with seeding and transplanting in that. So I've kind of given you the big picture and it all sounds great, but I guess probably a good idea to know where we're leading with that. So improved soil health is going to eventually lead to an increasing over time because it is a system. It does take a while to get there. You're going to start seeing results in the first couple of years, but you're not going to realize the full system until you get much further down the road. But we are increasing our water holding capacity. So more of the rain that is coming from the sky should be making it into your field and held there. We're increasing our structure and stability. So the soil that is on your field will stay on your field and it will not end up in the river, stream, or ditch heading off or in the low spot in the field to pile up or in your neighbor's field. We're going to increase organic matter. So all of that residue and plant biology that is going to break down is going to increase that residue. We're going to sequester more carbon in that soil, and organic matter acts like a sponge in your kitchen sink. It soaks up that water, so it really helps with that water holding capacity. It also has places for nutrients to be held in the soil so that we can hold on to those nutrients longer and keep them available for plant use. We're going to improve nutrient cycling because we're going to break down things and release nutrients from them naturally. So hopefully that will help with managing your nutrients for your crops. And then that enhancing and diversifying of soil biology and keeping that food web more complete is going to be a huge help in making all of these other things happen. So I have a little video. Normally when I am in person, I will do this live, but trying to switch back and forth with all the technical stuff that's going on, I'm glad I decided to do a video instead. This is called the slake test or the aggregate stability test. This is something that we do to show how soils hold up during a rainfall event. So these soil aggregates were collected from 2 fields that had different management practices. They're basically just collected. I went out with a shovel, got them, dried them out, and then we drop them in water. And this is going to simulate a heavy rainfall event because all of that water is rushing in to wherever it can get in the soil and exerting pressure. And you can see the one on the left immediately started breaking apart. It breaks into individual soil particles. So that water becomes really muddy. This is why when we get a rain and our rivers and streams look muddy, it's sediment that is coming from a lot of places, but some of it is coming from our agricultural fields. So put that on a slope, it's going to run into the nearest stream, river, ditch, and move on off the site, as well as anything that is attached to those soil particles like nutrients, pesticides, insecticides, anything that bonded to that soil is going to move as well. And you can see on the right, this is the system that has had that no-till cover crop practice. They've got a crop rotation. And it's holding together. So you can see it's barely budged. It actually soaked up all that water, held on to it, and anything that breaks off of this, which there are a few things that do, are still micro aggregates. So they're not individual soil particles. They are actually soil particles that are still held together in little aggregates. So that water stays clear. So if the soil becomes overwhelmed and it just can't take any more water during a rainfall event, this is why our fields that have these practices have clear runoff versus the runoff that would be coming off the field on the left. That was the conventional tillage, not a great crop rotation system, just because it has that soil health and it's able to not detach the soil particles as that water runs off. So this is a really cool demonstration we use a lot when we're talking about soil health. It's really impactful. It's really easy to see. And these fields are the same soil type. They were taken from right across the road from each other. It's just 2 different management practices. And I always get asked the question, like, why, when farmers see this, don't they just immediately do soil health practices? And it's one of those, the amount of money to switch over. You all are familiar with how expensive farming is. And I always tell people, especially people not in agriculture, no farmer is a bad farmer. There is no wrong way to farm, but there are ways that may be better for our soil than others. And this is a really good demo to show that. So that's my soil health portion. I'm going to go a little bit into NRCS assistance just to give you some overview. I know there has been a webinar on this as well already. So I'm going to do a real quick overview. So we've got 2 types of assistance, technical and financial. Technical is going to be your free advice. So set up a site visit. Don't be afraid to call your local office and talk to your local person in your NRCS office or with your soil and water conservation district. Normally they're co-located and both can be helpful. And you're going to get advice on how to work towards your concerns and work towards your goals and figure out how to address those things. And you're going to get a visit on site. Somebody's going to come out and walk the farm with you, talk through what you want to do, take a look at everything. And we can give you seeding mixes for plantings. We can give you engineering plans if you need to build something like a grassed waterway or a compost storage or something like that. And all of that is just free of charge. It is your taxpayer dollars at work. And then if you need some financial assistance to do that, Farm Bill programs can also help to provide some of that funding. So there's the EQIP program, the CSP program, and the CRP program that are our most common programs that we use. I like to break it down that EQIP is kind of the you've got a problem, let's fix it program. CSP is the you've addressed some of it, now let's take it to the next level. And CRP is kind of a unique program. It actually takes marginal cropland out of production to put it in things like buffers so that we can build that diversity and that habitat on those lower income areas of the field and get those practices installed. So that one is a little different. It is housed with our sister agency, Farm Service Agency, and we provide the technical on that. But if you call any USDA office, you'd be able to talk to somebody about it. And then finding your local service center. So this is our website for Indiana NRCS. If you scroll down, it has this nice green box that finds your local service center. And this map over here on the right, I pulled from one of our documents, and each of those dots is an office. So we have an office that covers every county in Indiana. We actually have an office for USDA that covers every county in the US as well as the territories. So there's always somebody to talk to somewhere. And that the best way to do that is look up that phone number, call that office, tell them that you want to talk to somebody about whatever issue you're calling about on your farm and that you'd like a site visit, and somebody will get you to the right person. And then some things to keep in mind. So I was a district conservationist for 10 years. So that is, I would be like the person that you would talk to on your site visit when I did that job. So here's some things that I always told my clients to keep in mind that hopefully I can pass along to you to be helpful. Have a goal or an issue you want to address in mind. Once you get out there, that might change. We might see other things that we talk about, but definitely have something that you want to talk about on that site visit, because we can't give farm business advice, but we can get you in touch with the people who can help you with that, like Purdue Extension or your other local land grants if you're outside of Indiana. We can connect you to farmer networks. We can connect you to other farmers, all that type of thing if you have those kind of questions. So don't be afraid to ask those questions, but that can't be the only reason for this farm visit, because unfortunately, we're not able to help you with that. But we can help you address issues or goals that you're seeing on your farm. And be open to new ideas, ask lots of questions, because you may call us out there for an erosion issue and we might notice that you have invasive species in your woods and want to talk to you about that. And we may ask if that's something you're interested in working on. So definitely be open to anything that's brought up. And then the site visit is going to result in a conservation plan. So it's your master plan to help you do things in a logical order and kind of keep you on track. And it's going to be spread out over time. So that conservation plan is going to help you kind of step through the process. And we don't want to overwhelm you and make you do everything all at once, because that can get really scary and never ends well for anyone. But getting it spread out over time and having that master plan to keep referring back to, and it's a living document, it's going to change over time as well. And then if you're looking at doing a program, just some reminders. Applications are accepted year round, but we do have cutoff for funding consideration each year. So our fiscal year runs from October 1st to September 30th. So until October 1st, Indiana is out of money for the year. So any application that you put in would not be funded. However, you can work with your local office on your conservation plan, getting that farm visited and getting ready to do that application. And you can put in an application. It's just not going to move anywhere financially until after October. And programs are competitive. So putting in an application doesn't guarantee that you're going to get funded. However, if you never put in the application, you're never going to get funded. So it's always worth talking to someone and doing that paperwork and figuring it out. And practices are paid at a flat rate. So if you end up getting funded and sign a contract up front, you are going to know how much you are getting for each thing you're installing in that contract. And they're paid, per acre, per square foot, et cetera. So as long as that footprint of that practice doesn't change, you know up front what you're getting. So that way you can make financial plans, and that should help you figure out what your investment is going to be. And then be patient, be kind. Obviously, the office should be doing this same thing with you, and you should be doing this with them. It's a process that takes a while, but communication, especially if you feel like something is not being addressed or something's going wrong and you want to change something, definitely sooner rather than later is the best way to do that. So just some little tips and insights from when I was a DC that I always told everybody that I thought might be helpful. And that is what I've got. So if you guys have any questions, let me know. I'm going to stop sharing my screen here if I can get technology to cooperate with me.
That was great, Amanda. Thank you so much. So one question is, could you explain a little bit more about the soil web that you mentioned in the earlier slides, and sort of what is that? How can we encourage that, and what sort of does that mean in a little bit more detail? Oh, I think you're on mute. Are you able to unmute?
There we go.
There we go.
Technology, I swear. We even tested before we started this. So no matter best laid plans, right? But so the soil food web is what we call all of our soil biology that works together, as well as our above ground things that are large macro organisms like birds and voles and moles and all of those things. So it goes all the way from stuff we cannot see, like bacteria, nematodes, protozoa, all of those things, all the way up to things we can see, like beetles, worms, all of that stuff that you would see if you dig up a shovel full of soil. So actually working toward a soil health system as we stop our tillage, which is what is turning up the system all the time and kind of resetting it constantly, which is why the system is less complete. It's super helpful because it starts to push the system into a more balanced system, because things like fungi that can't stand being physically broken up all the time because they have what are called fungal hyphae, and they form like a net or a network. Every time we do tillage and run over those, we break it into pieces and it has to start over, and some of those pieces aren't going to survive. So taking that physical disturbance out of the system, we are moving it more toward a more balanced. There's both bacteria and fungi there, and then as well as all of those other things. So earthworms are also especially important to the system, and they are intolerant of disturbance, because if you destroy an earthworm burrow enough times, the earthworm's going to leave because they're tired of rebuilding things all the time. Because they, especially the large nightcrawler earthworms, have very, very deep burrows, and those burrows actually, in a system that's undisturbed, will stay there for many years, and the worms will keep using them, and then roots will use them as well, so they provide channels for water to go into the soil. All of those things kind of play together. So really working on those 4 soil health principles, and the 2 things that really feed that soil biology are going to be those living roots from keeping those cover crops and things in the ground all the time, and then keeping that cover, because some of our biology is going to be what's eating and breaking down that plant residue that's there. And if you go online and just Google soil food web, there's a really cool graphic that I didn't put in the presentation. I probably should have, but it'll show kind of the interconnecting lines and everything of all these different types of soil organisms, and it's really interesting to look at.
Awesome, thank you. And then the next question is, what does someone who's never worked with the USDA, Farm Service Agency, or NRCS need for their first appointment with someone like you? Like, do they need a farm number already or anything like that? Or can NRCS help them get that?
Yeah, so NRCS can do a site visit at any time. They don't have to have already worked for us or have a farm number put together. But if they are interested in applying for programs, they will need to go through the process of getting a farm established within the USDA system. So there's a lot of confusion a lot of times with, well, I already have a parcel number from like my property. Is that a farm number? And it's not, because we can't read into county government systems. So we have our own USDA system with what are called farm and track numbers. And those are obtained by bringing in a copy of the deed and working with, and your driver's license, and working with that farm service agency person to draw out your property and get it in the system, and it'll assign that farm and track number. And that's something, if you call ahead with NRCS, farm service agency is also co-located with us. So normally what we can do is have you come in, we'll give FSA a heads up that you're coming, and we can walk you over, get you going with farm service agency. And then once you've got that farm and track number established, you can come back across the office and keep working on that other paperwork with us. So if you're just kind of curious as to what's going on and you just want some technical advice, it's not a big deal. We don't need to go through that whole process. But if you do decide that you want to try and do a farm bill program, you'll need that farm and track number. But most places it's pretty easy, as long as you bring in the correct documents and you have somebody a heads up that you're coming, they'll be able to sit you right down and get it done.
Awesome. And then are there any qualifications that farms need to have by size? So a lot of our veteran farmers who are just getting started, you know, they may have like 25 backyard chickens, maybe a dairy cow, a couple beehives, maybe they've got, you know, 10 sheep. Are any of the NRCS programs applicable to their size farm?
For sure. So we will work with any size farm. I have had farms that are 2 raised beds in somebody's
Nice.
backyard that they're using for like a roadside produce stand, all the way up to a big grain row crop farmer that does thousands of acres. So any size is applicable. And we have specific practices within our programs. If you are a smaller farm, normally we cap those at somewhere, you know, around an acre for those special program rates. But that kind of helps us give like a economy of scale if you're doing a cover crop or you're doing mulching or something like that. Because if we would give you the same rate that we give a big farmer, you're going to get like 20 cents versus, you know, the cost that you're actually going to be paying. So we're set up to work with just about any size of farm and any kind of crop, any kind of livestock. It can be anywhere from backyard to like a big operation. So we may have staff that are more comfortable with certain kinds of operations, but we do have resource people here at the state and area level that if somebody isn't comfortable within a field office working with a specific crop or specific size because they don't feel confident in their technical advice to that size of farm, we can find you somebody that can. So
that's great. Well, thank you so much, Amanda, for joining us today. In the chat, we have the Find Your Local NRCS office. And again, a lot of those service centers also share an office with FSA, but not always. We've also got our Veterans in Farming link, which is a way to get our free membership for our organization. And then we also have the USDA Veteran Farmer Resource Guide, and that's just jam-packed full of a lot of information for people starting up their farms. And it's also available in a lot of different languages. So if there's anything else, please feel free to reach out to Amanda and I, and I hope that you enjoy the rest of your day. And Amanda, thank you so much for joining us. Really appreciate it.
yeah, thanks for having me.
Take care.